Okay, so this will be on simulations. This will be page 5 and 6 of the note spiral. And please note this is the introduction to simulations. We will discuss problems in a later video. So, purpose of simulation. First of all, the simulation is to model data. It's a way of creating data. Now, as we've talked about earlier in the year, data is not perfect. Yes, we like to say something looks like it follows a uniform, or it looks like it follows a normal, or it looks like it follows a binomial, but it's never really perfect. And so when we use a binomial model or a normal, we're talking about a theoretical as opposed to what actually happened. Well, a simulation employs lots of randomness. So we get to see how randomness might impact our model, how much things may vary from what we are expecting, how much things vary from the model. And that's kind of the purpose of it. The other great thing is it's a wonderful way to collect data because it's so inexpensive. It's easier and cheaper to run than an experiment. It's also cheaper to run than an observational study or a survey. It's very easy to run and gets a lot of data very quickly. Now, one of the things about a simulation is you have to know something about the what you're studying. You have to have some idea as to the proportion of events or successes that you are expecting. Okay, so on the first page, page 5, you can kind of read through on your own. But once again, the purpose of it is to generate, to introduce randomness to the situation so that we can understand how much difference there is from the actual estimate or model and what would happen when we introduce true randomness to the situation. We have a recipe for success, and I'm going to go through this step by step because it's really important that you follow this and get used to following these when you're working problems. Some of it is very basic and you don't have to write down. Other parts of it you absolutely have to write down every time you do a simulation, and I'm going to tell you which parts are that case for. First off, reading the entire problem. Obviously, you've been asked to do that since you were in elementary school, but here it's truly important because you need to identify the question and what is being asked. There are several times students will give me an answer and go, hey, this is what I got. And what they got was actually correct, but it did not answer the question. So consequently, they're not getting credit when because they didn't answer the question that was asked. So please make sure you're actually answering the question. And this is not something you have to write down. This is something I want you to keep in the back of your mind and be thinking about as you're working this. You also need to identify a success, and a success is what we want to happen, what we are interested in happening. So like when we're flipping a coin, we want to know how many heads there are. We're rolling we're rolling a dice, a 6-sided die, and we go, hey, I want to know a success is rolling a 3. Or whatever that success is. Maybe success is an odd number. It doesn't really matter. We just need to make sure that we know what that is so we know how to model it. The component is something that's being repeated. It's what we're doing over and over again. For instance, when we're rolling a dice to get that 3, rolling the dice would be the component. The success would be getting the 3. Then we need to identify a trial. A trial might be, hey, the first time I get a 3, or maybe I need to have 10 3s. I don't know. The thing is we don't get to stop or say we're done until we've got the 1 3, or maybe it's 6 3s or 10 3s, whatever we choose it to be. We need to identify the trial when we actually get to stop running our simulation. All right, so these first 4, these are things you just need to keep in the forefront of your mind as you're working the problem. They're not actually things you need to write down. The next thing says model the simulation. Here you are. This is one of the things that's one of the most important things. And that means assigning digits because you're going to be working with a random number table. And I'm just going to put the one up on the screen real quickly. Here's a brief random number table. And these numbers are randomly placed there. And by the way, your calculator and computer do not create random numbers. It says it does, but it's run on an algorithm, so consequently it's not really random. if you really want a random number table, and the way these are generally created is they take a 10-sided die and they just sit there and roll that 10-sided die over and over again and record the outcomes, and that gives us true randomness. Okay. So we're going to either assign 1 or 2-digit numbers, and that's for our class. So you can assign 3-digit, 4-digit, or as large as you need to handle a situation. But for AP statistics, we're going to consider 1-digit or 2-digit numbers. And those 1-digit or 2-digit numbers are going to be your chances of success or failure. As we go back to flipping the coin, which is kind of my go-to standard, when we flip a coin, we get a heads or tail. Well, I didn't see a heads or tail listed anywhere on this table. So how do I model that? Well, we know 50% should be heads. So we could say 0 to 4 represents a head, and then we can say 5 to 9 represents a tail. So it's really important that we do some sort of assignment. Now, please remember, if you're working with 2-digit numbers, you're going to have a 0, 0. And the 0, 0 might represent a 0, or you might use it to represent a 100, because you might be going from 1 to 100, or you might be going from 0 to 99. It's up to you. I'm going to tell you that when you're running a simulation, you're going to use the fewest digits as possible. So if it's possible to use a 1-digit, then you'd rather do that than a 2-digit. If you can do 2 digits, you'd rather do that than 3 digits. So generally speaking, we want to minimize the number of digits, and we want to use as many numbers as possible. So we're going to assign all the numbers, but some numbers are going to be skips. They're not going to count for anything, all right? And you must always address what numbers are going to be skipped, if there are any. And in our first actual problem, we will have several numbers that will be skipped or ignored. And we will see that in the next video. The next thing is, are repeats permitted? Can we draw a number twice? And that's going to be depending on the problem given. It's really important to address percentages. It's really important to address duplicates. Typically speaking, if we're talking about a percentage, they can be duplicated. So basically, we need to make sure that we're assigning. That's something we have to write down. We need to address duplicates, whether they're permitted or not, and you can call them repeats or duplicates. Either one is fine. Once again, percentages usually cannot be duplicated. And generally speaking, if we're talking about people, they can't be selected twice. So when it comes to selecting people, generally speaking, they cannot be duplicated. But depends on the problem, so make sure you read it carefully. Then we need to explain how to run the simulation. And this is really straightforward and simple. We're always going to begin from left to right, and the reason is that's the way we read. All right? So we're always going to start from left to right, and you select 1-digit or 2-digit. You need to say which one you're selecting. Depends on what you've assigned. I selected 1-digit numbers, so I'm going to use 1-digit numbers. I'm going to select use 2 digits because that's what I assigned. Until there are a certain number of successes. Oh, I needed to get 4 3s to finish the trial. Well, if that's the case, it'll be 4. It's going to be determined by the problem, but it's very important that you also give that. And then at the very end, you're going to count how many 1 or 2 digits that were considered successes, and tell how many trials are going to be run. Oh, I counted up the number of 3s, and I had to do that 6 different times. Well, then I had 6 trials. And then you're going to take an average. All right, this is also something that you're going to have to write down. And once again, on the next video, I'll give you an example of that. Make sure you just make a table. This really just need to be a simple T-chart where you have your trial and then your number of successes or your number of counts. All right, and then you're going to ultimately take an average of that. So you're going to have to make a table, and then ultimately you're going to have to come back and take an average. And once you've done that, you're going to have to give a conclusion. And it's based on a simulation on above, or based on my simulation. On average, I would expect to have blank. And sometimes it's going to be I'm going to have to do something over and over again to find this many successes. Sometimes it's on average, we would expect to have this many successes, all right? But somehow or another, you need to answer the question. This is where you're answering the question, but it's always going to start off with based on the simulation above or based on my simulation, we would expect on average, or on average we would expect. And you don't have to be word for word perfect, but you need to make sure that your conclusion is answering the question. And this is the last thing that has to be written down. Okay, so that'll conclude this video, and the next video will actually run through a simulation.